The moment you flip a switch, something strange happens in your mind. The light turns on instantly, as if power traveled across the wire at unimaginable speed. Most people imagine electricity as tiny particles rushing through metal like water in a pipe, carrying energy from one place to another in a straight sprint. But that picture is deeply misleading because inside a wire, something very different is happening beneath what your eyes can see. The electrons inside the wire are not racing forward at high speed. They actually move extremely slowly, almost crawling through the atomic structure of the conductor, yet the effect of electricity appears instantly across an entire room. This contradiction creates a powerful illusion that we must understand carefully, because what seems like fast movement may not be movement at all. Instead, it might be something far more subtle and far more fascinating, hidden inside the structure of matter itself. To understand this mystery, we need to stop thinking about electricity as a river of particles and start questioning what is actually moving when the switch is turned on, because the answer is not what most people expect at all. It is not the electrons alone that carry the story, but something invisible that surrounds them, a field that responds instantly across distance. When one part of the circuit changes, the entire system reacts together like a connected network of tension. This means the effect you see at the bulb is not delayed by each individual electron traveling the length of the wire. Instead, it is the immediate response of an entire structured system waiting in balance. And that changes everything about how we understand speed itself. This realization opens the door to a deeper hidden physics that challenges everything we assume about motion and energy. To understand what is really happening inside a wire, we need to zoom in far beyond what the eye can ever see. Inside every metal conductor, atoms are packed tightly together in a rigid structure, and between them exist free electrons that are always in motion. But here is the first surprise. When you turn on a switch, these electrons do not suddenly launch forward like bullets fired from a gun. Instead, each electron only shifts a very small distance, almost like a gentle push in a crowded hallway, where everyone is already standing shoulder to shoulder. The movement is slow, controlled, and surprisingly limited, yet the effect spreads across the entire wire almost instantly. Yeah? So the real question becomes, if electrons move so slowly, how does the light bulb respond immediately? The answer lies in something far more powerful than individual particle speed. When you apply voltage, you create an electric field that instantly fills the entire conductor. This field acts like a command signal, telling every free electron inside the wire how to behave at the same time. The electrons respond locally, each one nudging its neighbor, creating a continuous chain reaction that passes through the entire wire in a fraction of a second. Okay? This is not a single object traveling from one end to the other. It is a coordinated response of countless particles acting together, like a perfectly synchronized crowd wave in a stadium. Each electron does not need to travel far because the influence is already present everywhere inside the conductor. The real motion is not of matter moving across space, but of information being transmitted through interaction. As this chain reaction unfolds, something even more surprising appears. The speed of this effect is not limited by how fast electrons drift, but by how quickly the electromagnetic field itself can reorganize across space. And that leads us toward a deeper question. If the field is responsible for this near-instant response, then what determines how fast the field can spread at all? Now we reach the deepest layer of this mystery, where everything we thought we understood about speed begins to change completely. We are no longer talking about electrons drifting inside a wire or even a chain reaction between particles. We are now looking at something more fundamental, something invisible that fills all of space around the wire itself, electromagnetic field. Okay? When you flip a switch, you are not pushing electrons across your room. Instead, you are disturbing this field. And here is the crucial insight. This disturbance does not stay in one place. It spreads outward through space at an incredibly high speed, close to the speed of light. That means the signal that turns on your bulb is not traveling through metal alone, but through the structure of space itself. This is where electricity stops being just a phenomenon inside wires and becomes something universal. Electric fields and magnetic fields are not separate ideas. They are different aspects of the same system. When one changes, the other responds instantly, creating a wave-like propagation of energy. This is why electricity and light are deeply connected. In fact, light itself is nothing more than a traveling electromagnetic wave moving freely through space. Okay? So the reason your light turns on so fast is not because electrons are racing through the wire. It is because the entire electromagnetic system responds almost instantly across distance, limited only by the fundamental speed at which information can move in the universe. The wire is just a pathway guiding the interaction. The real action is happening in the invisible field surrounding it. Right? And this leads to a final realization that changes everything. Whenever you interact with electricity, you are not just dealing with moving charges. You are witnessing one of the most fundamental behaviors of reality itself, how the universe communicates through fields, not through objects,